All right, this is our final concept, concept I. We're going to be looking at the final type of reaction, double replacement reactions. With this, again, we've seen this general formula before. This is when two compounds basically switch partners. Something that we call precipitate is going to be our insoluble salt. So we often refer to this reaction as a precipitate reaction. We can also refer to it as a neutralization reaction to form salt and water between an acid and a base, and our water in this case has to be pure liquid. Alright, we're going to be using table F again. This is going to help us complete and balance the following double replacement reactions. We're going to be writing the formulas just like before. Now we're going to be determining our precipitate or our insoluble salt, which is going to be a solid, using table F and balancing our equation as usual. So here we're going to be switching both partners. So we have SR and AG, which are going to simply change places. We still need to make sure that we are balancing our charges. That's why SR has to be bonded to two NO3s, and then AG is just simply bonded to one Cl. And we'll take care of that by balancing it later. Now, again, using table F, which we talked about, NO3, we find on table F here, NO3 is always going to be soluble, so that means any ones that fall under the soluble compound are going to get an AQ. AgCl, though, if we look at Cl, we see that it is combined with Ag, so it is an exception, which means that it's insoluble or that it's going to be a solid. So you're going to be filling that in with a solid form. That means that that is our precipitate that gets formed. So we can go ahead and balance it to make sure that everything is taken care of. Again, you may want to label this as your precipitate, because that's what we refer to our solid that's formed during a double replacement reaction. So moving in, we're going to switch places of the positive ions out in front. So Pb and potassium are going to go ahead and take care of that. So now we have potassium with our acetate ion and lead with iodine. So if we go ahead and find acetate is right here, we can see that there are no exceptions. So acetate and potassium bonded together are going to be aqueous. And if we find iodine again, we do see that it is bonded with lead, so that means then that it will be our insoluble salt in our solid, which we refer to this being our precipitate. Alright, now just like we did before, we're going to balance our equations. So make sure you have the 2's in front of the two potassium compounds. And then we're going to go ahead and do our net ionic equations. Just like before in our previous concept, our soluble salt that gets formed is composed of the spectator ion. So it actually makes it a little bit easier. So already going into this, we know that this compound and the ions that make it up are going to be our spectator ions that we're going to take out before we get to the net ionic. So as you can see here, I've separated out all the aqueous ions into their separate ions. And then for our net ionic, again, we've already said that this is our soluble salt, meaning that these pieces that make it up are going to be our spectator ions, and we can take them out. So what we're left over with is our lead ion, Pb plus 2, plus the two iodine ions to make PbI2. And it should already be balanced because we balanced it above and correctly transferred down the coefficients. So that's all that it takes for that net ionic equation. Going ahead with this one, we can see again that LiNO3 is our aqueous ion. This is going to be made up of our spectator ions. So again, breaking apart everything, all the aqueous you can see separated out on here. We do know that the LiNO3s are going to be taken out, so we're getting rid of the lithium and nitrate ions, leaving us with our net ionic equation. So we have our iron plus 3 ion combining with our 3 chlorine ions to form iron chloride. Alright, so that's it for that one. So pretty similar to what we did before. And finally, we can look at it as a acid-base equation or a neutralization reaction. We have our acid plus our base to make water in liquid form and our salt. A net ionic, because again, I'm not going to write out the total, but we know that this is going to be our spectator ions. So I know that Na would be taken out, and so would erase that. So would chlorine. So we have hydrogen and OH that are going to make up our water. So you're going to see that as our net ionic for our neutralization reactions. You'll always just about see our positive hydrogen ion plus our hydroxide ion making water. Okay, that's it.